In this problem, we have a random variable x, which is uniformly distributed between -2 and 2. And we transform that random variable with the function y equals to g of x. That looks like the solid line in this figure, where the portion here is y equals to x, and y is also here x, and y is 0 between -1 and 1. And what we are required to do is to find the density function of y as well as the distribution function and plot it. So the first thing that immediately comes from the statement here is that I can find the density function and distribution function of x. And because I know x is uniformly distributed between -2 and 2, I can straight away plot both the density and distribution function of x. So the density function looks like a rectangular function between -2 and 2, where the height is 1/4. And the distribution function will be a linearly increasing function from being 0 at -2, going all the way to 1 at 2. Okay, so now I'm required to find the distribution function of y first, which can be written as capital Fy of y. By definition, it is probability that big Y is smaller than small y. Right. So as we know, x can be between -2 to 2, and y is transformed such that y is also between -2 and 2. So this is the range of y. So the possibilities of y taking a small value y can be, for example, this y can be somewhere between -2 and -1, or y can be somewhere here, or it can be exactly 0, or it could be between 0 and 1, or between 1 and 2. So these are all the possibilities that the random variable y can take. So let's write down the distribution function of y for each of these possibilities. So let's say now y is between -2 and -1. So the probability of big Y being smaller than y means the region where the black solid line is below this blue line. So in this case, if this is the blue line here, the black solid line is below this line in this region, which translates to x being in this region, which means from -2 to this point here, which, because the equation of the line is y equals to x, this point here should be x equals to y. So this can be written as the probability that x is between -2 to y, which again is fx of y minus fx of -2. And fx of -2 here is just 0, because we can see it from here, right? So this can be just 0. So it turns out to be just capital Fx of y. For the next possibility, when y is between -1 and 0, the x has to be in this range, because the black solid line is below this line, this blue line here in this region, which translate to the x being here. So this means that the probability that x has to be between -2 to -1, which is just fx of -1 minus fx of -2. And again, this fx of -2 is 0. The next possibility is that y is exactly equal to 0, which means this blue line here. And for the curve, for the black solid line to be below this blue line, the x can be in this range, which means that the probability x has to be between -2 all the way to -1, which is again fx minus 1 minus fx minus 2. Again, this will be 0. Similarly, the next case, when y is between 0 and 1, the x, so the black solid line will be below in all of this region for which the x is between -2 and all the way up to 1. So I'm sorry, I made a mistake here. It should be +1 here. Okay. So x has to be between -2 all the way up to 1, which is again fx of 1 minus fx minus 2. Now the last possibility is that y is between 1 and 2. So that means the x has to be from -2 all the way up to this arbitrary point. And because as we know, the equation is y equals to x, so this point will be x equals to y. So this probability can be written as probability that x is between -2 to y, which is fx y minus fx of -2. Right, so now we have obtained this distribution function for y. And if we want to sketch this, it will look something like this. So this is y. This is big Fy of y. This is 0, 1, 2, -1, -2. So before -2, it is 0. And between -2 and -1, it is fx of y. That means we take this region from fx between -2 and -1. So we just plot this. That means this straight line here. And between -1 and 0, it just stays at fx of -1, which is this point here, and that is 1/4. So it just stays at this point. And when y is 0, we go all the way to fx of +1, which turns out to be this point, which is 3/4. So at 0, we jump to 3/4. And for between 0 and 1, it stays at fx of 1, so it stays at the same value. And between 1 and 2, it takes the value of fx of y between 1 and 2. So we pick the fx function from 1 and 2 and plot it here. And after that, it's just 1. Right, so now we have obtained the distribution function of y. And the next step is to find the density function of y, which is small fy of y. And by definition, it is just the derivative of the distribution function. So So if you plot it first, this is y, this is fy of y, 0, 1, 2, negative 1, negative 2. So we see the slope between before negative 2 is 0. The slope of this function after 2 is also 0. And the slope is 0 between -1 to 1. And because there is this jump here, we will have a delta function at 0 with the height of 1/2. And these lines are just constant slope lines of 1/4. So we just have a constant function here. So now we can simply write the density function as it's just 1/2 if y equals to 0, and it is 1/4 if y is between -2 and -1, and it is 1/4 again if y is between 1 and 2. So that's the density function. And if you have a closer look, this density function integrates to 1. So the area here is 1/4. The area here is 1/4, and the remaining 1/2 is here. So if you sum all this, you get 1. So it's a valid density function. And if you integrate this, you will get this figure here. So that's the end of the solution.